Thank you for joining this lesson. We're going to handle statistic graphs, and we shall start with histogram and frequency polygons. So we are told the table below shows the masses measured to the nearest kilogram of 100 people. So we have the masses here in classes, then the number of people having the given classes. We are told to draw a histogram and a frequency polygon to represent the data above. So what we're supposed to know about frequency polygons and histograms, we can draw a frequency polygon from a histogram. So we shall start with the histogram in this case. So the first class, as we can see, is a 40 to 49. Then we have 50 to 59, 60 to 69. The classes are uniform in this case. The classes are uniform. They have the same intervals. And so now, for frequency, not a frequency polygon, but for a histogram, we need to plot frequencies against upper class limits. Frequencies against upper class limits. So I will start with frequency on the vertical axis. And as we can see, frequency is ranging from 9 to 22. I think the highest frequency here is 22. So for us to accommodate between 9 and 22, I think we can use intervals of 2. Intervals of 2. That will accommodate everything. So now, what we need to do is to ensure that we label the axis to contain all. So if we start with 0, we can go to 2, 4, 6, 8, 10, 12, 14, 16, 18, then 20, 22. The next one will be 24 according to the scale. So these are the frequencies. On this side, we plot frequencies. Frequency F is plotted here. Then on this side, we're going to plot the upper class boundaries of each class. And as we can see, the least one is the least class boundary from the data is 39.5. Therefore, I'll begin with 39.5, the least class boundary according to the data, so that I may run up to the highest class boundary, which will be 109.9. Therefore, when I start with intervals of 10, when I start from 10, that is 0 to 10, you realize I will have how many bars from 0 to 10, 10 to 20, 20 to 30, 30 to 40. Those classes will not be in use according to this data. Therefore, it is advisable, instead of starting from 0 in the x-axis, I break the axis and I start with the least class boundary, which is 39.5. Therefore, I will start with 39.5, so that I go to 49.5, 59.5, 69.5. Then we have a 79.5. Then I go to 89.5, 99.5, 109.5, then 119.5. Now, after breaking the axis, now I use those intervals. So if now I start plotting each class, or rather each upper boundary with the respective frequency, then I shall start with the upper boundary in the first class, which is 49.5 against 9. So 49.5 against 9. 9 is between 8 and 10. So that is the first upper boundary. The next one is 59.5 and 19. So 59.5 goes with 19. This one goes with 19. So 19 is somewhere between 18 and 20. The next one, which will be 69.5, will go with the 22. This one will be the highest class. This one goes with 22. Then after 22, the next one will be 18. This one will be against 18. So 18 is here. The next one is going to be against 13. So 13 is in between 12 and 14. The other one is 11. So 11 is between 10 and 12. So 11 is here. And finally, we will have a 109.5 against 8. So the last one, 109 against 8. So these are all the upper class boundaries against the respective frequencies. So this means now we can join all the coordinates to the x-axis. Remember, this is now going to be the first class. This is going to be the first class in our data, whereby the frequency is 9. That is the first bar in the histogram. The next one, the next bar, I want to realize that the upper class boundary of the first class becomes the lower class boundary for the next one or for the preceding one. Therefore, the other class now ends at 59.5, but it began at 49.5. Therefore, we join this one now to get the next bar. That's how it will be. The next one begins from 59.5 with the upper boundary of 69.5. So that is the other class. Then the other one will be ending here. Remember to be subscribed to our channel as we continue studying. So that's how the bars for the respective classes are supposed to appear. We connect the coordinates to the x-axis and we complete the bar. We complete the bar for each class. So these are now the classes represented on what we call a histogram. So this is a histogram now representing the data. We can see this is the largest class. The largest class, 59.5 to 69.5, having a frequency of 22. So now, something else which has to be noted is that now with a histogram, we can plot easily a frequency polygon by joining all the midpoints of all the classes. Therefore, we identify the midpoints now of each bar. Therefore, with the bars of histograms, we just identify the midpoints of each bar and we connect them using very straight lines, not curves, and that gives us a frequency polygon. Therefore, if frequency polygons are to be drawn without a histogram, then we just plot midpoints of the respective classes against frequencies. That gives us frequency polygon. So the first midpoint and the next one have to be connected with a straight line. Then we connect to the next one, using midpoints, straight lines. Then we connect the next one, using a very straight line. Continue connecting. Continue connecting. Continue connecting. So now what we should understand is that the frequency polygon now does not have to remain suspended. It has to be anchored on the axis at the lower class boundary of the first class. The lower class boundary of the first class. So this first midpoint, we anchor it at the base of the axis that way. Then the last midpoint, we anchor it at the upper class boundary of the last class in this graph. So that is how the frequency polygon and the histogram are supposed to appear. These are upper class boundaries plotted here.